overview of how the software works. And UL Solutions in itself provides a lot of different solutions, including if you would see your charger, the battery is certified by UL. The laptop chargers, Apple iPhone chargers, all these are certified by UL. Solar panels, wind turbines, we are in all testing and certification scenarios. And Homer software itself helps with economic optimization of power plants, renewable energy power plants. So as I think you already have been aware that the future is hybrid. We are going for not only for coal plants or diesel plants, we are looking for all the different solutions and to get a reliable energy supply. So whether it is solar, storage, microgrids are the trending ones, especially for village power applications where we are not able to meet the requirement through grid. It's quite expensive to bring the whole grid infrastructure to remote locations or island locations. So in that case, the future would require distributed energy resources. And that is where we provide support with our primary software, the first software with which Homer came into existence. So that is Homer Pro. But now, since we are seeing a lot of different applications coming up with grid connected systems, and then we have two other softwares which are dealing with grid connected. But the main focus with which Homer came into existence and with which we have been helping people around the world to develop microgrids and distributed energy resources. So this is UL Solutions history. This was started back in 1894 as a basic, very simple idea of having safety, fire safety. The two founders faced a safety fire problem, and they found that we do not have any safety procedures to handle that. And they, from that little idea, this whole company has come around with a 130 years of experience. We have around 500 plus renewable energy engineers. In 2019, Homer became part of UL, and Homer itself was created as a PhD project. In 1992, the founder, Peter Lilienthal, he did his PhD project with Homer software. And from there, this was privatized back in 2009. In 2019, we became part of UL. And recently, this February, we released our latest software called Homer Front, as you can see in 2022. So this is a little bit of background. These are our key office locations. As you can see, we are existence in 140 plus countries, but these red spots, as you can see, all these little points, these are all our major locations in different parts of the world. We have around 500 plus RE experts. We have 35 years of experience in renewable energy, helped in building 100 plus certified different solar plants, wind power plants, etc. We have more than 100 plus already existing projects where we are helping in different sectors, different levels, from the initial design concept till the implementation, and even after the implementation, we provide support, consultancy, owners, engineer, etc. And about Homer, we have helped in building and modeling more than 1 million power projects. And in UL, we have used and forecasted more than 100 plus gigawatts of solar plus wind projects. About Homer. So Homer itself stands for Hybrid Optimization of Multiple Energy Resources. We help in economic optimization of different grid connected or off grid renewable energy systems. So we are dealing with minimizing the cost, how we can best utilize different infrastructure, different resources available in the area. And from there, how we can optimize the whole system. So this is where Homer came into existence, and this is what it is helping with. It helps with all these three different systems, standalone microgrids, as you can see, where you're not connected with the grid, or you have an unreliable grid where you can bring it or it's not there, you're facing some resilience conditions, etc. And then we have these grid-tied projects, distributed projects, where, as you can see, like commercial buildings or even your this institute has a solar plant. So it's taking the benefit of that. It's if it is giving back to the grid, it will have some cost benefit. So trying to reduce the utility bill is where we have another software that's dealing with specially grid connected customer side of the behind the meter systems, and then front of the meter systems, where you're completely directly dealing only with the grid, where you're putting on big plants, 100 gigawatts, 150 gigawatts. You must have heard about these tenders coming out, so big tenders. So they just put the plant and they sell back everything to the grid. They are not utilizing it for their own use. Here in this institute, you will be using it for your own. If it is extra, then you will be selling back to the grid. So that is behind the meter system, and front of the meter is where you are selling back everything. So we have Homer Pro, which is dealing with standalone microgrids, Homer Grid, which is dealing with behind the meter applications, and Homer Front, which is dealing with front of the meter applications. This one will take around, all right, this one will take around half an hour. If you want about this one.
No, no. I'm for all that. I don't want to waste the time.
Okay. So that would take around 1 hour. Around 1 hour.
Both the versions?
Yeah. Yeah, I will just show all this number. So this is basic idea of what are all these three software deals with. Homer Pro is handling our standalone systems. It deals with village power applications or island grids or different systems, mines, campuses, bases, these kind of solutions where we are trying to build and trying to provide electricity to remote locations or trying to have a reliable connection. In that scenario, Homer Pro can be utilized. You can try doing sensitivity analysis, optimization of those software of that location. Then Homer Grid comes into existence, where we are trying to deal with this part of the grid behind the meter, where we are just dealing with these customers, CNI customers or residential customers. You're just trying to reduce the utility bill in this particular location by peak shaving, energy arbitrage, or other kind of methods, and trying to reduce demand charge reductions. And then we have these home of front, where you can deal with the home of front is actually dealing with the grid connected system in the front of meter. So I can share the presentation with you all, so that you can access it even afterwards. So generally, for each of the software, the process through which Homer deals with any kind of system simulation is the input that you require. Since it's a software, you need to provide some input, and then only it will be able to give you results. So the input includes economics. First, project economics is the main important parameter for the components, the cost, what you will be leading to, the project cost, the land cost, etc. Those costs are required. And then we'll have some site specific resources, because we are going to try and implement and utilize the existing resources, solar resource or wind resource, hydro, hydrogen, whatever kind of resources are available in the area. The resource data needs to be provided to the software. And then we have the components. What kind of components? Because even if you have solar and wind, probably you will be just going with one of them, or just utilizing solar plus storage or generator. So the kind of resources are available, but the components that you're going to utilize, and then associated cost of those components. These are the inputs, and then Homer will run its analysis. Now, the analysis is this three-step paradigm that Homer follows. At its core, it's a simulation engine. It runs all the different system scenarios. It tries to figure out what's the associated cost of all these systems. And then it tries to optimize. Optimize is where it will try to give you the best fit solution. And now the criteria for defining how you're getting the most optimized result is trying to figure out which one is the least cost system. Any project financer will always try to figure out which way you're going to reduce the bills or reduce your project economics. So the most optimized solution would be the lowest net present cost. And then you will be getting the opportunity to add sensitivity analysis. Now, sensitivity analysis is, it basically tries to answer questions like what if diesel fuel prices increases or decreases. Since if you have a diesel generator in your project, the main operations and maintenance cost comes from the fuel, the diesel fuel. So if the diesel fuel price increases or decreases, as you would have noticed the Russian scenario, we are facing a lot of fluctuation in the diesel fuel price. So that affects the project economics directly. It is going to affect the whole project scenarios. They would have done some other calculations, but right now they would be paying something else. So to understand how a project economics would change, how the whole project cost would change by getting this kind of scenario, you can easily implement that in the software, and then you can get hold of the results and you can try to understand, okay, this is what we are going to deal with, even if it goes extra. And then with all these calculation, it provides you with the results. Now the results are all in different ways, different financials you can get, economics, the performance details of each of the components, how they are going to perform in the whole year. All that information you will be getting in the results. And the best part is you can get all these in different graphical representations. You can find, you can plot these answers, you can plot those results, and you can easily, because we are able to deal with graphs much more easier than the tables. So we have both of those. You can look at the tables and the graphical representation of those results as well. So that is how you can, even you can export them, you can view them, you can utilize them in the reports and directly just provide it to your in the here. I think you will be able to provide it to your professors, but in real life scenarios, when you go for the projects, you will be able to present your reports directly to the clients with whom you're dealing with. These are some of our clients in different parts of the sectors, developers, and etc. So I will be trying to cover all the main points of all of our softwares. So this is about Homa Pro, standalone microgrids. This is what Homa Pro deals with. It provides you with a flexible simulation. You can go with whichever kind of design you want to move and one component at a given point of time, you can do that. You want to experiment with different solutions and you want to try out which one is better, you can easily perform those solutions. You can play around with the economics. You can try what kind of interest rate would be better, what kind of inflation rate, how that is going to implement, and how that is going to make a difference to the whole project economics. Then we have a lot of different options then where you can look at the climate impact, because that's now gaining a lot of importance. Many times you will have to show how much CO2 emissions your project is going to bring around. Then a lot of different evaluation methods like sensitivity analysis is one of them, the major feature that you can utilize with the software. These are some of the applications. We have telecom sites, island, hydrogen connected systems, wind, solar components, etc. Then we have the equipments that can be modeled include all of these. We have all these components that can be modeled using Homa Pro. As already discussed, the inputs include all of these: load, equipment, the system cost, and the resource data. And then Homa Pro will run its analysis and provide you with the results with like which one is the least cost system, but it will provide you with all the different results associated as well. This is showing on how Homa would be presented. So this is the main page. As you can see, this is the basic design page. And here you can select your project location. And in this page, you can get some suggestions like what needs to be done to getting started. And here you can provide in your project location, the coordinates or the name, or even this graph itself can be utilized for pointing out the project location directly if you want to pointed through the graph. After the project location, the main point is to get started with the project design. And the project design would include our electric load. The electric load, we have these four different types of synthetic load that's already available. If in case you do not have your load data, then you can get started with these synthetic load data available in our software directly. You can directly use them. You can play around with these numbers. So you can see over here, we have different options to the pointers. Anyways, oh, it's coming. It's okay. So we have these different points where you can edit the data. You have variability function and a lot of other options where you can play around with this. You can scale your data. This scaling factor is there where you can just scale the whole data to a different value. If this, since this is a synthetic load, it may not be exactly what you're looking for. The project may not be having the same low kilowatt hour requirement. So you can scale that data up or down from this option. Then you have other options as well. You can model thermal loads, you can model hydrogen load, you can play around with these. If you have your own data, you can import that data, and you can even use our OpenAI database. Then the schematic over here provides you with the different options. Here we have all the different components that can be added in a system in Homer, all that added over here. So we have hydro, hydrogen, generator, electric load, thermal plants, the thermal options, wind turbine is there, hydrokinetic, thermal load is there, all these different storage, battery is there, PV plant is there, all these different options for designing your system there are available in the software. And then you have, you can select whichever you want. It's not required that you need any one particular, depending on the project location, depending on the resource data that you have. According to that, you can select which one you would want to move forward with. And then the system controller is there. Maybe it's called dispatch strategy that you would have heard during your classes. So dispatch is how any of the component is going to meet that load. At any given point of time, how the project, how the load would be determining which component is going to serve that load. Is it going to solar? It be solar. Are we turning on the generator at that point? Are we going to meet that from storage? So that decision of making which component is going to meet that load at a given point of time is dealt with controllers. So we have 6 different controllers that's already defined in the system existing, the real-time controllers that are there in the market. According to that, we have developed these controllers and it's already fed. But if in case these dispatch strategies do not meet your requirement, you have this option of creating your own dispatch through C++ or MATLAB. Here we have entered all the components, but to run these components like PV, wind, hydro, all of these components would need their own resources. So this resource tab over here, the third option, would provide you with the option to enter these resources. All the different resources associated with these components can be imported from here. And that is how this would look like. You have this resource data, the numbers, the monthly representation, all that you can look at here. You have fuel, temperature, solar for PV, wind for wind turbines, etc. All these resource data is available. And this one is for the whole project. So till now we have dealt with the load, we have dealt with the components and its resource, but what about the whole project? It's not just these different components. It would take the whole project to come into existence. And for that, there can be some additional cost that's not included in any of the components. So you can input all of these over here. And if you want to provide in any of the constraints for the project, like there can be some load that you want to miss or you can afford to miss, then in that case you can apply capacity shortage, etc. Any optimization or these sensitivity analysis cases. So I will be showing the software and it will be more clear than this. And once we have settled down with the whole input scenario, the project inputs are there, load, components, etc., then we can figure out our results. So as you can see over here, this is how our results would look like. And each of the result will have this simulation result. So each system scenario, each system architecture, which will have its own simulation result, how the PV is handling at that point, how your storage is being called, how your if you're added in a generator, how that generator is dealing. All these information will be available here in the simulation result. A 1 year simulated, 1 year data would be there here. And in the cash flow, you can get the information of the whole economics for whole project life. Any questions, Tulia?
This practice since 2009.
This was a project. This was started as a PhD project by the founder. He was handling this and he was creating projects on just for his research purpose. And then after that, he started seeing. So this was created as a project for meeting the requirement in Caribbean islands. There, they try to utilize wind turbine and remove the diesel genset. From there, this was then it saw more requirements, and in the US they started getting requirements like we need to optimize situations, and earlier this can be actually handled with Excel sheets, but for each scenario you will have to run that Excel sheet, and it's very difficult to track all of those Excel sheets, and try to figure out when you're presenting how will you explain all of this, because this will give you the example, this will give you scenarios in just one single graph rather than going to each of the Excel sheets. So that's why this was preferred in comparison to the older methods of using Excel sheets. And from there, since they saw the requirement, then it was privatized. Anyone else?
Say that no standalone microwave anywhere. It can be used in anywhere. And how it is different from just big
Home grid is where you have the grid connected system already existing. Like in this case, grid is connected and you can utilize the solar panel infrastructure also. So grid will have its own tariff. Tariff rates are there like till 200 kilowatt you will have to pay 4 rupees, or after 200 till 400 you have to pay 4.5 or 5 whatever, and after that again. So those complex tariff structures cannot be handled by HomoPro, and that is why we have to create another software called HomoGrid that's handling grid connected systems. And then peak shaving is there where it tries to minimize the load requirements during peak hours when the grid is already under pressure for meeting all the peak requirements, which is compulsory. Then it will try to reduce. You will find outages in the residential area, but not in industrial, because industry cannot miss out those loads. So either it can be done directly by the grid or it can be done on our own level. We can try to meet that peak load using solar instead of like pressurizing the grid. So in that case, peak shaving, the dispatch is what Homo grid can handle, not Homo. इंडिया में बैंगलोर, यूएस में गोल्डन. So there are some case studies where Homer Row has been utilized to present their or create their case. So here in this case, as you can see, we head with large off-grid hybrid power system. So this was a big solar plant. Beva is a renewable energy company, and they were using Homer with a dispatch strategy, which we helped them creating using MATLAB. And there they utilize. So this is the existing solar plant that they utilize, and we helped with these graphs and all the whole case study scenario. So this is where we were engaged, and all these information you can read through. You helped in utilizing the resources available in the area and the solution, which one would be the best fit solution for those cases. And the dispatch that in accordance with how they wanted to prioritize PV in what time, etc. That was handled using Human. Then Kilowatts for Humanity is an NGO which is working for these little communities in African countries. So they're trying to build these little uh, kind of these little what do you call it? Microgrids, mini grids, little mini grids. A whole complex is there. The whole community is being served by this little solar plants and storage. Storage is inside this building, and then on the top they are putting up these solar plants. So with how much they are going to pay, how much this project cost would be, all these we help with creating all of that. They had the idea of how much the size of PV would be or what battery size they would be going for. And we help them deciding how long these would work, what would be the impact, how much they can. So there is another way where they were trying to get these money. I don't remember that name, but yeah, some. So these, if you're going to charge your mobile phones or if you're going to charge your these lights for night, in that case they will be paying. You will be required to pay for that requirement. Otherwise, just little one bulb and one fan will be provided directly for the whole community. So how much that requirement would be, what would be that load profile, they provided us with that, and we created the solution for one, and now they have been replicating all that in different parts of Africa. Beliza, we created the energy independence. So there they were trying to get rid of the grid connected system. They wanted to be completely dependent on their own resources. They wanted to put their own plant, solar, wind, all these different options. Storage should be there so that they can compensate with the unavailability of solar or wind. So in that case, Homer helped with trying to bring around the different technologies that can meet these requirements completely being off grid, and how much that would cost. So this was till now about Homo Pro, and this is about Homo Grid now, and it's very much similar. The main application is different. This is handling distributed generation. As you can see over here, this is an EV charging lot. So the solar over here is just trying to charge these cars over here. So the it is grid connected. If in case solar is not there, still the electric vehicles would need to be charged. In that case, grid will come in and meet that requirement. But in other times when we have the solar requirement, solar availability, it will meet the EV requirements. So this is one of the example of what Homo Grid can handle. And these are other options. As you can see, we have solar, wind, storage, all these different options, CHP, EV charging, all these different options that can be modeled using Homo Grid. It's very similar. We have the options of creating different uh, these varieties of projects where we can try to deal with all these existing resources and minimize our customer bill. And that's what it is dealing with. We can use it for PV complete independence, or if we have to use it for trying to reduce the bills, and how we can make benefit of, let's say our rooftop is there, so how we can utilize the rooftops available. Similar, the main difference is the tariff over here. Because this is dealing with grid connected system, you'll need to get tariff that is associated for the grid connection. So here other things would remain constant. You can add incentives because many of the countries are providing incentives if you are putting a if, solar plant or wind turbines, if you're putting it on your rooftop or some available land in your community or something. and every country is trying to promote that and they provide incentives for it. So you can model those incentives using homogrid. You can put down the tariffs that it can handle, system components, load profile, all these different options are there that can go in the input as here. Then homogrid would run around its simulations, try to figure out all the different options, and then provide you with the results. What would be the most optimal solution? What would be providing you with the lowest net present cost and providing you with the information of how much saving you're doing on your bills. So this is the main page, very similar to Homer Pro, but as you can see, it's a little different. The main top over here has changed to the left and your schematic would be on the right. Other than that, main basic difference is this utility point over here that where you can enter the tariff rates. You can define the load in similar pattern, same the four options of synthetic load, or you can access the OpenAI database, or you can directly import your time series data. The utility tariff, you can create your own tariff. Very complex tariffs can be created using these, or you can directly, if you are building a project in US, Mexico, or Canada, then you can directly utilize the tariff database over here. We have collaborated with Genability, which has around 16,000 plus tariff that's available here for different US locations, and you can directly utilize. From here, you can select components you want and enter the resources in a similar fashion, and then select which one would be the desired solution. And here we have CHP also. You can build your own thermal load in the similar fashion. You can add synthetic load, you can import that, or you can add the boiler or electric heat in this case. You can calculate these fuel costs, emissions. You can change the resource also for boilers, and those options are also available. The when you have a grid, you can always expect it to have some shortages, some kind of capacity shortage or anything where like a grid outage completely. So in that case, you can build that as well. So these resilience and reliability conditions help you with building the like trying to incorporate those situations like small shortages or the larger ones where it would be happening like in 4 years or 5 years down the line. So you can model those if you, the grid has provided like a complete maintenance schedule that they go in 4 years or 5 years. Those can be incorporated. In resilience conditions or reliability can be shorter outages during the whole year. And you can define your incentives here. If you're going for solar or wind and the countries are providing you, the government is providing an incentives, you can build that. Or demand response events can be also incorporated. This is EV charging. You can create your EV charging load, what kind of chargers are going to be used, what vehicles are going to come and being charged. All these different options are available, and you can add in those highway charging, office chargers are there. Night charging is there, where in the morning office complexes will be using the load, but in nights they are all off. So in that case, they can use the overnight chargings for EVs, and highway chargers are there. And once you've incorporated all of these different options, then you can understand the results. So in similar manner, the results would be very similar. You have these simulation results where you can look at the savings in your utility, where you can provide information about your IRR or your net present cost. This little graph over on the right, if you see, this is showing how your system is like working throughout the whole year, which component is trying to meet the load requirement. And this is how we can directly create reports. You can create and it will get You will get a copy in Word file, even in PDF. So you can directly just utilize that. These are all editable at different steps. As you can see, we have all these different options where you can provide your client information, your company's information, all these can be provided over here. And in since you can get that in document, you can make changes to it. You can copy it in your presentations the way you want to present it. Any questions?
And firstly, with the app, we say that that we have to select the area from the map. So that is it covers the hilly area or the forest?
Yes.
Forest.
On the map, you can select.
When the results get given are based on real time information or like manually?
It won't be real time since these database, if you have heard, Meteonorm is there, NASA data is there, solar resource data. So from there, we are taking those resource data for every location throughout the world. For those locations.
Like they have been building the data. Can we find out like one of the data?
Yeah,
Get
it is showing that.
availability of the site on which day and which locations data is.
Yeah, the day will not be there because it's already like I think 2012 data is there for NASA. So those 14 or 16, that data is there. So you can select which year, which data you would want, NASA data or NREL data, and for me again, I'll be showing.
Which style of file is required in both of them.
.csv. That would be complete 365 days worth data you would need.
There is any option that we do want to design a system for specific things of the appliance, or it's standard like if you want to take a pen, it's 75 watt fix or
No, load, it will not consider like you're considering only fan or tube like that. Bifurcation is not there. You'll have to combine all the load and input that directly. But for components like PV or wind turbine, which component you're going
okay,
to use?
deliver site we
that
can,
information.
but the load side there is
Load, you will have to create that data because load is an input data. So you will have to get an idea of what kind of load you're trying to meet, how much is your everyday's load, kilowatt hour requirement of each day, and that you will have.
like if we want to use the if for the function of switching or the
Automation is not there. So it is just trying to figure out the optimization. Like if you want to
of course starting you mentioned about the demand side.
demand side, you can get the idea, not the implementation. Because automation is like you will require the information of that like at any given point of time. That would be real time. This is a static software.
We have also mentioned about the MATLAB in starting. So if we have a MATLAB models, can we import out some derivatives?
MATLAB model for dispatch strategy. How you're going to, how the PV is going to be called if you want to define that instead of what we have already. Maybe you want to prioritize generator instead of PV. In that case, you can use MATLAB. But it's not like handling at any given point of time. It's going to provide you with the whole year's data.
In the, like in the optimization, if we are going to use it for the optimization of processing in the what the economic point of view. So like there are there is any list of for the different optimization techniques we use in that we have in the
Those are the dispatch strategies that utilizes. But the main funda through which it works is that it is trying to reduce the bills, reduce the economics.
there are a number of optimization techniques. So which one is Verma is going to use? Either we have the list, we can the user can select their own, or it's by default.
The optimization technique cannot be selected because there is only one optimization, that is it will try to reduce the economics.
Which technique?
That is an algorithm that has been defined especially for this software, that it's like a proprietary information, and that algorithm is used to optimize.
So if we would like, we want to do a case study with different optimization techniques, so that can be given with
dispatch strategies, two different dispatch strategies you can utilize, but optimization only one is there. It's same for Homer Pro, Grade Up, and all that. It's always trying to get the lowest net present cost. And these are some of the options where we utilize Homer Grid, because as you can see, this solar rooftop is being utilized over here to match the requirements for PV, or even trying to get benefit of the incentives in those locations. So this is where Homer Grid was utilized. We have done demand response incentives, the incentives that they get because for implementing a solar on the rooftop. So those incentives can be utilized. And we have tried to consider the impact of these EV charging stations inside the office complex, where we can utilize their night load with the EV charging options. So here also Homo Grid was utilized. And how any industry or a community will be charged because of resilience conditions in the grid. If any outage comes, you'll lose a lot of energy in that case. And if there are some machines going on, if it's a factory or if it's a company where the laptops and computers are working. So in that case, if you face an outage, it will have a cost impact on it. So what cost that would include, what would be the resilience and reliability conditions impact, you have those we helped in calculating over here in this case. This is about Homo front. So it's like a utility scale storage where we are just dealing with the revenue that these components will provide any power plant manufacturer, power plant implementer. So in this software, we can just handle solar storage and wind. This is our newest product. It was launched this February 2022. And here we can utilize utility scale generations. We can provide in the benefits of battery augmentation. Like if we face the batteries deteriorate with time. So what would be the impact when we are trying to augment it, when we are trying to increase the battery size, let's say in 2 years or 4 years or 5 years? That would have a better impact on the whole project economics. So battery augmentation can be included, and the cost impacts can be included in here. The basic remains same. You have to provide in the input. It will provide you with the simulation and provide you with the results. These are its key capabilities where Homer front can we have model and utilize DC coupled system where you have PV and storage, and then it is trying to provide you through the inverter. It is trying to sell everything to the grid. So these you can get information about the how much you're going to get benefit, what's the revenue basically, and how you can integrate that, what you can import, export, all these values can be adjusted. This remains similar. You can set up your project where you can provide your inputs, the market, how that market is being served, the capacity market or energy market, revenue streams can be added over here. And power purchase agreement, if you're getting with the grid with a power purchase agreement, what's the cost of that power purchase agreement? Or if you're getting involved with the time of delivery contracts, then what's the term of those kind of contracts you can input over here. And model setup would something be like this, and here you have your results. So these results can be looked at. These are our revenue streams and price charts, how you will be getting more benefit if there is some peak demand in the grid and you can sell back more to the grid in that point. In that case, how much benefit you're going to get throughout the year or throughout the project lifetime. These revenue benefits can be included. Let me show the software and then probably it will make more sense. All right, so this is how the software looks like. When we open the software, you'll find this little icon, this self-help kind of thing that gets you started. So you can see some of the sample files which are labeled, and a system setup assistant is there, and you can utilize that. This is one of a sample file that I have opened, and this is a village in Cebu, Philippine village, and we have tried to meet that requirement, a small community load requirement, using diesel, wind, and solar and storage. So we are trying to look at all the different options that's available there and figure out which one would be the best fit solution in this case. So whenever you open the software, you can select your project location through this option. You can just click on anywhere on the map and it will take that particular location. Or you can point out like this, zoom in, zoom out. Different views are there from which you can select based on your options. And even here in this address bar, you can point out your project location or you can put out your project coordinates. On the top, if you see here on the right, these resources are there from which you can select if you want to use the database, the solar database or wind database, then these are the different options from which you can select. For solar, we have NASA and NREL data. For wind, we have NASA data, and for temperature, again, we have NASA data from which you can select. Then in this description, it's provided all the different options that have been considered. So whether you want to go for solar, wind, what's the economics that have been considered for the project lifetime, all these different information can be provided over here in the description so that you can, like, if you're revisiting your project file after some time, you can get an idea of what you had considered at that point. Then some of the project inputs you can provide over here: discount rate, inflation rate, annual capacity shortage, etc., and the project lifetime. These little icons, if you see on the right of each of these variables, these are called sensitivity variable editor. So this is what helps you with looking at different sensitivities. So as you can see, annual capacity shortage has 3 sensitivities added. So if you see here, we have 0, 2, and 5 capacity shortage. So you can allow no capacity shortage, that all the load needs to be met at any given point of time, or 2% of the load you can try to avoid, or 5% of the load throughout the year you can try to avoid. So what would be the impact of this capacity shortage? How your project economics is going to be affected by this? You can look at that. And we have these 6 different loads that you can model using the software: electric load, temperature load, thermal loads, and a hydrogen load. Here in this case, we have a primary load that has been added. It's a synthetic load, one of the village power applications. These are the options of the load. If you have your own time series file, this would be added over here. And then OpenAI database can be utilized for US locations. And then in the profile, we have, if you're going for a residential load, a commercial, or an industrial load, in that case, you can use the synthetic load profile. So one of that has been used over here. This is how the node data looks like. You can look at all the different nodes. So it's all same, all 2 and 7. Like hourly data is remaining constant. But we have these options over here in which you can even look at the graphical representation. So this is how your first month of the year data looks like, the average of it. You can look at these. The numbers over here have been presented on the graph side over here. This is the seasonal profile. So at any given point of time, any month, you can look at the average, minimum, maximum of that month from here. So as you can see, the peak is 4.54 kilowatts. So you will be able to figure out which month that one is from this graph. This is another representation of your whole year's load data. So as you can see, this one is showing day of the year on the bottom and hour of the day on the left. And right, it is showing the kilowatts. So the warmer the color, the yellow or red ones, those are the more load conditions, the higher load conditions, and the cooler the color, the down ones on these basically the morning options. These are all low load conditions and those are represented with darker colors. So another representation of your load profile. And we can scale this data up or down. So as you can see, this data was 157 kilowatt hour per day, but then it has been scaled down to 35 kilowatt. So we can plot that. You can look at your baseline data versus your scale data. So this is your baseline data, the red one, and then it has been scaled down to blue. And this will be now considered to evaluate in the project, this one. Then we have these 15 different components from which you can select. Here in this case, we have selected generator, turbine, PV, and storage. And there are other options also. You can select hydro, hydrogen, hydrokinetic, even unreliable grids, thermal load controllers. All these different options are available here. For adding any of the component, we have two options. You can select from one of the generic ones that's available in our database, or you can go for a particular manufacturer. So then manufacturer can be selected from the catalog. So these are all the different manufacturers that's available in our catalog. Based on capacity, based on manufacturer's name, you can filter them out and select which one you would want to move forward with. In this case, we have a diesel generator already added. It's a 6 kilowatt generator. The cost associated is provided over here in the cost table, and then the sizing table helps you with the size of that particular generator. Site specific inputs, minimum load ratio, how much the generator can go down to remove the low efficient conditions. Those parameters can be fixed over here. These are all provided by the manufacturer, the generator manufacturer. They will, in the technology catalog, you will be able to get all these values. CHP feed recovery ratio, if you are modeling this generator in a thermal condition, then you can input these values. Any minimum runtime, if a client needs the generator to be turned on for, let's say, 400 hours or 100 hours at least. So in that condition, you can provide in these number of minimum runtime for that generator. And if the generator is already existing in that project, then you can provide in this initial hours for the generator. And which bus this would be connected, you can select from here, electrical bus and some advanced properties over here. So these are few resource, what kind of fuel you are going to use for the generator, the price, and here you can see again three sensitivities have been added for diesel fuel price. So we are trying to look at how the project would be when it is very low diesel fuel price, a medium diesel fuel price, or a high diesel fuel price, how the project economics would change. Then we have fuel curve, how the generator is functioning. You can look at the efficiency curve over here. And then we have, you can see this area. It is a low efficient area. Here it's a gradual decrease, but from this point it's a very fast decrease. So to avoid the generator running in these low efficient conditions, we apply minimum load ratio. Co-parent with biogas, we have emissions that can be controlled, or what we can get those numbers for the generator and incorporate in your project to get an idea of when the generator is functioning, how much the emissions would be. Consider the maintenance scheduling, and like overhaul or any kind of maintenance if it is required, you can add in that. Even you can fix your generator if it has to be forced on at any given point of time. Let's say the client says generator should be turned on in this particular time. Then in that case, you can add in these numbers, this forced on condition for those months, or any particular month if you want, these numbers can be added. So depending on these conditions are generally provided by the clients, if that is provided, then you can provide these options over here in this chart. And similarly, like diesel, PV also has its own advanced properties, but the costing and sizing table remains same. You have cost table where you can provide in how much the capacity cost would be there, and then you have sizing table where you can provide in the information like what range of optimization should be done. So 20 panels, 20 kilowatt, you can go more from here in this case. So Homer optimizer is the sizing is utilized with Homer optimizer. This is the algorithm that tries to figure out what size would be the best fit size. In this case, we can provide a range from which we want. Like there is land available, and you can't go above 15 kilowatt or above 20 kilowatt.
It is covering the shadow area.
That you cannot cover in this. You can add indirect. This is so if you're doing shading
From
analysis,
the previous, we can
you can import data. Yeah. Or even if you're using previous from same way. So previous is if you're utilizing that, we accept the latest version exported data. So you can directly export that file from there. So .csv and this kilowatt value should be there. And you can input those values when you are inputting, when you import the file over here in that range, you can provide in that this would be the cost for this particular size. And then it will try to optimize the point. So both options are there. If you want to plan and utilize panels, then in that case you can select from here, from the catalog, which manufacturer you would want. CC library is there from which, like, it's a huge library with all the different panel manufacturers data available. So you can select from there also. And based on size, lifetime, etc., you can select that. And otherwise, if you're going for any PVSys or previous scope data or PV sold, then you can use directly the PV production data.
And how many types of battery we can configure in?
All the different kinetic batteries, vitalized batteries, lead acid, lithium ion, LFP, all these different options are there. So even in batteries, you can see you can filter them out based on chemistries. Nickel ion and vanadium flow, zinc flow, zinc vanadium, all these options are there. Any questions?
Question?
So particular area पर सेटअप कर तो वो उसका वेदर भी फोरकास्ट भी यूटिलाइज करता है सही
Forecast नहीं कर सकता because this is trying to utilize the existing resource data. As you can see here on the main page where I selected the project location, here we have the resource data already available. This is not a real-time data, it's already there, which it is just taking out from the website. So it won't be able to forecast.
There is any option
So-
if you want to execute some other site data here, like we have
Yes,
this system.
you can import it. You can import.
Offline. Like from our system or
Yeah.
from the website directly you can import.
If you have from the website, you can download and then import. So here in this resources, you can see if you're going for solar GHI. This data is also imported data. So with these options, you can import. So it needs to be .csv file and all the numbers like if it is an hourly data, it would be 8760 values. So that kind of data would be there. That directly import that. So I think meteornom is generally used for solar GHI, so you can utilize that directly. Same goes for all other options. Wind turbine, if you want to import the wind data, wind resource data, or solar DNI.
And then any hardware we require to export the control or whatever we are operating the control units from here to the field devices. We require any hardware like in the MATLAB they have inbuilt in the simulation they have inbuilt boxes. So we need to connect to
Simulation
export
software.
the,
So
connect the or to export the whatever the output we are getting to the field devices.
So the difference between MATLAB and Homer is that MATLAB is a simulation software, which is it's not optimizing it. Whatever you are inputting the data for PV or generator or anything, you're just trying to simulate how this is going to work in the real life. This is trying to do economic analysis. economic analysis can be done. So how, like for the whole,
Can like that's why I was asking. Like in the MATLAB, we have the whatever the different optimization technique. Either the problem is linear or non-linear. For all the techniques, we can write on the code and we can execute it.
so for the whole project, like you get net present cost, I don't think that's available.
Not for the whole, like for the particular.
And that is what. So this is trying to look out for the whole project lifetime. Because if you want to implement any project, you'll have to go to the bank and present that this is what I'm going to pay. I do not have this much. I will have the ground plan. I will have the manufacturer's data. But this is what I have to pay, and then they will bid on some particular thing. So that report is what Verma provides. The project whole economics that Verma provides. Basically, the financial analysis. MATLAB is doing the technical analysis.
Yeah, that is
This is
giving
doing
it transient even.
transient analysis and power flow analysis. Those can be done. So those comes after you have figured out what project you are going for. That is the implementation stage. Here you are going for the development stage when you are trying to look out what different options are there, and when you're trying to figure out, okay, we want to move forward with a 10 kilowatt of solar and a 3 kilowatt of wind turbine. So those options, why this? Why only 10 kilowatt? So that will be get that.
When number of solar panels and generators you have to provide, or you will pay for time.
You can provide if you want, but the Homer optimizer, if you're selecting this option, Homer optimizer, which is selected over here, then it will provide you with the option like what numbers is best. Otherwise, the search space option is where you can provide in the exact numbers, whatever is options. Like sometimes Homer optimizer will give numbers in decimals, so 5.67. That kind of panel is not available. So in that case, you can go for search space and optimize it. Like we have 5 kilowatt or 8 kilowatt, then only we can provide. So in that case, we can provide that option. Any other questions?
मैम अगर वेदर फोरकास्ट नहीं हम करेंगे तो जो परफॉर्मेंस का एस्टिमेशन निकलेगा उसकी एक्यूरेसी कैसे हम
Weather forecasting itself is a different domain. Forecasting जब प्रोजेक्ट लग जाता है then you forecast. क्योंकि
प्रोजेक्ट लगाई जाएगी तो हमें पहले पता ये चलेगा कि अगर उसमें
आने वाली क्लाइमेटिक कंडीशन के हिसाब से कैसे परफॉर्मेंस मेंटेन होगी.
So right now, I don't think there is any forecasting technique which is 100% accurate. It cannot. Solar PV, wind turbine, these are all intermittent in nature. You cannot predict that. जो ट्रेंड चल रहा है फ्रॉम 30 ईयर जो पहले से आ रहा है, इतना भी डिफरेंस नहीं आता. हाँ, पोल्यूशन से डिफरेंस होता है, क्लाइमेट चेंज से डिफरेंस आ रहा है, एंड वी आर ऑल फेसिंग दैट डिफरेंस. बट what we have from behind us from the past, that data has been added. हर जगह government has put up these solar resource gathering equipments जो हमारे पास solar data MNRE provide करती है, and you can access those data. If you want to put it in your project, you can purchase that data also. So हर जगह का resource data is available, and that resource data you can utilize to just get an estimate. कोई भी project economics हमेशा 100% accurate नहीं है, but you can get an idea. अगर ये 4 करोड़ का project है या 10 करोड़ का project है, तो it can be 9.5 or 10.5, but it won't. So वो 30% का ratio हर कोई लेकर चलता है, जो भी financiers हैं उसमें, they understand that it is going to have an economic impact. ऊपर भी हो सकता है, नीचे भी हो सकता है. गवर्नमेंट भी उसमें हेल्प करती है, तभी इंसेंटिव्स मिलते हैं या उसकी फंडिंग होती है. ये सारी चीजें उन सारी चीजों को इनकॉर्पोरेट करके लेते हैं. लेकिन हम चाह रहे हैं कि ये चीजें ना हो. वी एवरीबॉडीज मनी इज इम्पोर्टेंट. तो फोरकास्टिंग इज अ डिफरेंट डोमेन. जहाँ पे वो प्रोजेक्ट लग चुका है, देन यू आर गोइंग फॉर फोरकास्टिंग, और यू कैन फोरकास्ट फॉर अ ईयर इन एडवांस. 1 साल कर सकते हो, लेकिन जब प्रोजेक्ट बनता है, सोलर इज नॉट गोइंग फॉर 1 ईयर. 25 साल के लिए जनरली उसका लाइफ टाइम होता है, या 20 साल के लिए, या 30 साल के लिए. सो दोज व्हेन यू आर गोइंग फॉर दैट प्रोजेक्ट लाइफ टाइम, आप फोरकास्टेड डेटा पे रिलाई नहीं कर सकते. आपको फिर से फोरकास्टिंग भी तो पास्ट डेटा से ही हो रही है. तो हम बेसिकली, क्योंकि फोरकास्टिंग इटसेल्फ टेक्स अ लॉट ऑफ इनपुट्स, टेक्स अ लॉट ऑफ टाइम, तो फोरकास्टेड डेटा भी आप यूटिलाइज कर सकते हो अगर आप एक्सपेक्ट कर रहे हो कि आपका प्रोजेक्ट 2023 में लगने वाला है. बट ये सॉफ्टवेयर आपको 2025 के प्रोजेक्ट को भी आप इम्प्लीमेंट कर सकते हो. अगर आप सोच रहे हो कि यू आर गोइंग फॉर द लैंड विल बी अक्वायर्ड बाय इन 3 years maybe, so in that case you can predict your inputs and what kind of models you are going for, what kind of modules, PV panels you would be going for. So that can be done here. But forecasting is only for some time. This is for the whole project lifetime. And that would be required for any project financer. वो एक साल पे देखकर तो नहीं दे सकता ना आपको 25 साल का सामान, इसलिए. Any other questions?
It's like we have a multi sources and we want to select which one will the combination of which one will be the cheapest one. And your priority may be the budget, your priority may be the CO2 emission, different things may be there. So we are selecting, okay, if we will go with the renewable, like we want to minimize the CO2, okay, we should go with the wind, solar, and other biofuels, etc. And if our budget is the target, like whatever you are using to select the car, either we should go with the petrol fuel or the diesel one, or I said whether we should go with the EV. And our features are also the constraint over there. So based on that, we select it. So that thing
That
can be done with the AirPods.
and if you are buying a car, you will need money. तो वो money हर कोई ये चाहेगा कि क्यों दूं मैं. So with that
minimum amount
that
is maximum.
distance. So whatever your priority is, whether you're going for the lowest net present cost, whether you want to prioritize more renewables, key, we want to have everything renewable, we don't want to rely on generator. So in that case, you can remove the generator and see how much cost this project would implement. All those scenarios you can look at directly over here. This was earlier being done with Excel sheets. All we used to model a lot of different financial analysis, and from there we'll take out these results from these Excel sheets and do all those macro things and then figure out that this one is the best fit. But there are a lot of assumptions over there.
We also consider the interest rate.
Project economics.
It's totally basically on the
financial science. So this Homer optimizer can be used for sizing, and then again advanced properties if you want to explicitly model an MPPT, orientation, default slope can be added in, tracking system if you're planning for a different tracking systems for the PV plant. If you want to consider temperature effects of the PV, then you can add these percentages. These are all provided by the panel manufacturers. You can include that. Same goes for wind turbine. When you're adding, you can add from the generic ones or use the complete catalog. And this is how the turbine can be added. You can add in the cost. You can add in the sizes that you want to consider, whether you want to go for Homer optimizer or the search space options. And then some advanced properties like power curve, turbine losses, maintenance. If you want to add, all these different options are here from which you can select. Hub height of the turbine, etc. And then we have storage. Again, similar pattern. You can select from the generic ones, or you can look at the complete catalog, filter them out based on chemistry, based on model, ASM, flywheel, supercapacitor, idealized batteries. All these different options are here from which you can select.
Can we configure ourselves like if we want to add some brand here?
So for adding any component, not only storage, any component, you can go to the library over
Can
here.
we make our own library?
Yes, from the existing one. If you have a storage but that capacity or that power curve is not clear, the losses are not included, it's not correct, then you can go to a particular one and copy, and then everything can be edited. So with this copy button, you can make your own. You can change these names. It will appear something like this. Once you make any change, it will come up here in bold. options. So these are all edited options. And same goes for other components. They can be added as per the resource available in your area. If you have hydrogen requirements, you can use that. Fuels. Fuel can be added from here, the fuel resource or hydrokinetic options. And then project economics. So if you have the discount rate or interest rate, so what interest rate would be there, you can apply sensitivities on this. So you can see if you're getting it very cheaper or very like lesser than that, very expensive. All that impact you can look at here in the discount rate, expected inflation rate. If you're assuming that probably inflation rate will be high if I'm going to put it in 3 years. So you can look at the effect of inflation rate also.
You can add another.
You can add, as you can see here, 2 turbines are there. You can add more also.
I'm not talking about the number of turbines. I'm talking about types of turbines.
Like for example, which type of wind turbine we are using? The liquid induction generator or DC or permanent?
That is there in the catalog. You can get information about that. You will be able to look at the manufacturer, or we have SAM library, so you can like import other options also, output type. And so basically the output does not make much difference if you have the power curve correct. In wind turbine, the main feature is power curve. How your system, how your turbine is reacting with the wind speed. If you get the power curve correct, any component will be fine. Whether it is the vertical index or horizontal ones, all those will be all like the wind application, how it is going to perform is dependent on power curve and turbine. So if you get these two things correct, it can be any manufacturer. You will be able to get that number.
What about the toolbar?
Here,
You can also add the number of
there,
from where you select the turbine and solar hydropower. There we can also add the other ones.
other like what component?
And there are only when there are too many sources in there, too many hybrid systems are also available. And I'm talking about that.
Hybrid systems are created by using these options. Solar plus PV plus storage. What kind of resource you're taking? Like wave can be added in hydrokinetic, hydro plants can be added in hydro component. So all the different
It can
components.
be easily work on based on the hybrid system.
This is a hybrid system already. You can see here. You have 4 different components that is meeting that load at this point. Here, in we are dealing with a hybrid power system. We have 2 turbines, a PV, a generator, and a storage. So already this is a hybrid. You can add more. You can remove some.
Then what is the breakup temperature? It is the result is about on the climatic and
Uh, so temperature does not affect everything. Like PV is affected by temperature, PV panels. So there in the PV, when you're modeling the PV, in that case, you can add in the temperature effects.
it does not think about the season.
When you're adding temperature effect, it will automatically take it back. Because the resource data is according to the season. It's taking the whole year's data. So winter, summer, everything is included. Any other questions, anyone?
Then what are the minimum system requirements to have the software?
To have the software,
Software is not for
you can download free trial. That is 21-day free trial. After that, you'll have to get the license. It's a licensed software, and for creating any project, you will need a load and a component. which will meet that load. Basic thing is the load that you're trying to meet and the component which will feed that. So these two is the basic, but the more you try to optimize exact cost, then exact numbers results would be the right options then. So in that case, you can modify it further and bring it to the real scenarios. That is there in our website. I will show that after this. Any other questions, anyone? Any other questions? All right. So from here we can select our resources, then inputs of the project. Here you can add in multi-year option if you want to look at the, so we can assume that the load might change in the coming years. Then you can look at that impact in the multi-year option. But that is an advanced level of trying to perform your analysis. And we have all these input reports, etc. So once you have settled down with your project, then you can click on this calculate button and results would look something like this. So we have a summary which will provide you with the information of which one is your winning system based on net present cost. So you can see the base system, which was only generator, this is $102, but your winning system is $76,000. So this is the difference when we bring in PV, generator and battery in this case. So based on if you apply some capacity shortage and you say the wind turbine speed would be high in this case, then it is suggesting for a wind turbine. If the diesel fuel price is high and wind speed is also high, then in that case it will suggest for wind plus PV. It's neglected the generator. If it is low, it will ask for a generator in this case. Remove the wind turbine. So you can look at the winning solutions through this graph and try to understand what's the impact of different simulations, different options that you've provided. And then we have tables view, sensitivity cases, all these different options are here. So zero capacity shortage, the lowest diesel fuel price, you can see when the wind speed gets high, it tries to suggest wind turbine as a better option. So whenever we have a high wind speed, it is going for wind turbine instead of PV. So this is what the hybrid option is. You can select which one would be a better option. So based on if you have a good resource data, if you have a good wind in the area, you can go with wind option instead of solar. Same goes for this. But for any scenario, if you go down here in the optimization results, you can see when your wind turbine is better. You can see this one is $86, but it can have any other important feature. So you can see renewable fraction is more. If the wind turbine is there, it is trying to add in more renewable to the system. So depending on what is your priority, whether you want to get the lowest price or whether you want to add in more renewables, whether you want to maybe reduce the diesel fuel usage, diesel generator usage, according to that, you can select which component or which model would be the best fit solution. So all the models that are selected are available over here that you can see. Overall would give you the long list of results that's gone in, and calculation report over here provides you with the number of solutions. So these are the number of solutions that have been modeled in this software right now. But if you would have done it in Excel, look at the number of Excel sheets that you would have done to reach this kind of data. So that is the main feature where we are trying to figure out the different financial aspects of a project directly in this software. If you want to look at any given model, you can double click and simulation results will be there. So yeah, here is the cost summary. This diesel is, this much is the diesel percentage. This is your wind turbine storage, cash flow will provide you with the tables of every year, which component is coming in at which point, etc. You can compare it with the only diesel generator option, like why is it expensive, why is it cheaper, or anything like that. Electrical view, it will give you information of the production, the consumption of that load, any access electricity. So wind turbine is there, it is giving us so much of access electricity. Renewable fraction, fuel summary, how much the generator is being utilized. And so this graph will show how your generator is coming in. This is your wind turbine, and input, mean output, penetration, losses, all these information will be provided over here in the battery, losses, the energy in, out, autonomy, throughput, batteries, how many number of batteries are there. All these information can be received from the simulation result. Then there is this time series plot. So this shows when your system or when your load is met by what kind of component at any given hour. This is hourly data. These spikes are showing you the wind turbine power output. This green is storage, and you can like put in any other options also. You can zoom in to get a view of like a whole week, how your system is coming in and how your system is responding at any given point of time, and even hourly. So any given hour, how your load is being met, you can look at that. So wind turbine is coming in and then it starts meeting the load. It's quite high in comparison. The diesel generator goes down in that point when the wind turbine is kicking in, and your storage remains constant. And here it is trying to charge the battery and discharge it when it is trying to meet the load only with the battery. It has turned down the generator, this orange is generator. It has turned down the generator, meeting the load only with the green option over here. And when the wind turbine comes in, it will try to charge the battery and meet the load accordingly. So at any given point of time, how your system is responding, you can look at that information over here. So how your wind data is, if you want to look at those data, the profiles over here will give you the wind speed of every month, an average of those, or diesel fuel usage. Or, input power, anything, whatever you want to add in, whatever you want to look at, all these different options are there from which you can decide which one you would want to present. Same goes for DMAP. Each of the components DMAP can be available, wind speed at any given point of time, what's your primary load, all these different simulations and their graphical representations can be taken. And this can be exported in Excel also if you want this particular time series plot and you want to look at more information. So that is on the side. Sorry. Right. So over here you can see this other option from which you can export your data. And exporting table options is there where you can look at the table view, table numbers, wind speed at any given point of time. Every hourly data is available over here if you want to get into those details. And if you want to present this to your client, you can create your proposal directly over here. So this creating proposal, we have two different options, plan proposal and engineer detail option. So you can make edits, make changes to these So whatever your client name is, if you want to provide in any client title, the position of that person, so whatever that location, the name is, all those information can be provided over here. And then the company information, if you want to provide over here, your name, the company information, testimonials, you can add more, you can remove these, and your report section. So you can remove any of these. You can change these options. You can change the order of these report. So these are all editable and given at different points. And since this is a document that will be created, so you can open that report at any point. I will open one. This is how it looks like. This is a document file. You can make changes, provide in any name or whatever information you would want. And this is your the current system. So it is trying to provide you information like why this hybrid system is better than the current system. Will provide you with this information and all those gaps, etc. And every component, how they are performing, what's the detail, what's the DMAP, all these information are available over here. Yes.
It will be directly downloaded from the
From the software, you can directly.
automatically generated.
There are two types of reports. Huh?
I'm asking things something and they can make a project with the number.
हम लोगों को इतना टाइम लगता था ये सब रिपोर्ट बनाने में.
No need to type everything is just
Everything is auto-populated. You can just directly take that. Even make presentations with all these graphs. That's there.
It doesn't know about the homework you can make to them. They are beautiful to
You can add more information or directly use this. So this is the cash flow at any given year-wise numbers are given. Like when you're putting in money, when you're getting out those benefits, all these information is provided over there.
So in this we also add the payback period.
Payback period is
it also change the configuration. We change the configuration.
payback period will be provided as an output. You will get that value. Yeah. So this system which I selected is expensive than the generator, so it's not providing. This one is the cheapest one, and if you go to compare economics, you can get those. What's the present worth? What's the annual worth? Return on investment, internal rate of return. This will be divided. And what exactly is the definition? How it is treating the inflation rate or interest rate or any economics, any calculations, your period production data. This is being handled from. You can look at those calculations from the user manual over here. So Homer calculations, these provide you with the data of how Homer calculates PV array output or radiation or your what's the kinetic battery model, what's the inside of it, how it is calculating the autonomy or the losses of it. All these information is provided over here in the manual. What basis Homer is taking it to decide. And if you go for the economics, here you can get those values, what's your tabular mode, your graphical mode, etc. And you can look at these results, simulation results. So how these are calculated. If you want to look at how calculate button works and all these different aspects of the software, everything is available in the user manual article. Every topic will have its own, like the load, how the load is being added, cash flow, how cash flow works, what's the compare economics. Everything is available in the user manual article that you can access. And about the license, so this is our website, homenergy.com. These are our different products. I have shown these Homer Pro and Homer Grid. So if you even want to like get more information, you can look at this Homer Pro information over here. And this will provide you with all the basics. How this optimization is done, it provides you with the information. So this is a proprietary algorithm that I did. And from there it tries to, like, basic information is provided, like how that is done, etc. A lot of different materials are available. What are the different modules? If you want to look at that, that is available. We have this 21-day free trial that anyone can utilize. Your it will be logged with your email ID and your computer, so you can use it for 21 days, get an idea of how the software works, all that. And if, we have like special licenses, especially for the classroom purposes. So you can take like one license, and then we have like 40 CPCs based on the number of strength of the students, and that is quite um, discounted because of academic purposes. So if you are interested, you can let us know if there are any requirements. Then you can even start from like 5 seat and get an idea and then like, add on afterward. And all these different services are there. So we do provide consultancy and engineer hours. So if you're stuck with any project, we do support with that also. And here is the pricing option, but the academic ones are not available over here. Uh, these are the shared license option, and here you can select. But for classroom, you can let us know if you want, and then we can provide you with the right numbers. And here we have the support page. So anytime if you need any support from the software, you're stuck somewhere, you're not able to understand, the user manual article is there in the software. But if you want more help, an online version is available. We have video library. Sorry. The YouTube channel is there from where you can look at all the different videos associated for this software, where we have taken an introductions, or we have presented any particular um, like part of the software. All these different options are there, like determining the resilience and microgrids, how we are dealing with that. All these information are there on our website. We also have this knowledge base article. So there are, based on topics, we have a lot of different articles. 300 plus articles are there here. So based on which topic you're more interested in, according to that you can access. If you're like the one customize your components, so you can look at those options directly from here. So how you can create your own custom component, adding custom components, those related uh, articles are available on our website itself. And then we provide trainings also. So this one is just a demo one, but we have other trainings based on the level of interest we provide.